Hello, welcome to section 6.8, Conditions for Congruent Triangles. As a review, we're going to look at the last three conditions to have congruent triangles. So the first one, the first one we learned is side angle side. And what that says is if I have two triangles and they have two congruent sides and an included angle, then these two triangles are congruent. So if this is ABC, this is DEF, we could say that triangle ABC is congruent to triangle DEF by side angle side. Okay. Next we have angle side angle, and what that says is that if I have two triangles that are congruent, or if I have two triangles and this has a congruent angle, a side, and another angle. If these two triangles have two congruent angles with an included side, I have angle side angle congruency. Here I have side angle angle, and we'll go, let's do side angle angle, side angle angle. Here we have two angles and a non-included side. If I have two angles and a non-included side, that is side angle angle, and those are also congruent. Now today we're going to learn about a fourth condition for congruent triangles, and that's called side-side-side congruency. And what that says is that if I have two triangles and they have all of their sides are congruent, then the two triangles are congruent. And I'll show this to you in a practical way rather than just going through the theorem, proving the theorem, because I think you guys will remember it this way. All right, so what I have over here is I have a set of 3 sticks. And I'm going to move so that I have a better thinking, so you can see this better and I have a better setup. So here I have, I have a set of sticks, and then I have another set of sticks, and these are all the same length. So the blues are the same length, the yellows are the same length, and the oranges are the same length. So for this first set, what I'm going to do is I'm just going to make a triangle, and you guys need to stay where you're at. Okay, so here's my first triangle. Now with this set, I'm going to try to make a different triangle. I'm going to make that angle a lot bigger. And, oh, wait a minute. That's not working. I don't have a triangle, I just have 3 sticks that are together. So I'll have to move this. Oh, but look at there, if I keep moving that, it's just going to keep going down. So now I need to move this in so that they can touch. Oh, there we go. And look, I have 2 triangles that look exactly the same. Even when I tried to make the triangles different, I couldn't because the sides were all the same length. So what that shows you is that when you have 3 sides of of 2 different triangles and they're congruent, this is the only shape they're going to make. So when we have 3-side congruency, the whole triangle is going to be congruent. Okay? Let's scooch that out of the way. And come back over here. All right. So now we're going to see how we can use these properties here to do a proof. All right. So I have example 1. So this is example 1 in your book on page 253. And you can follow along in your book, and I'll just explain how we're coming to these answers. Okay, so for number 1, they've given me this diagram here, and they're telling me that ZX bisects WZY, and it also bisects WXY. Well, what do we know? we know that's given, so we're going to start with that. We have ZX bisects angle WZY and angle WXY. That's given. Just going to do that to make it easier for me to see. All right, so it bisects those two. I know that if a line bisects an angle, that both sides of that angle are going to be equal, which means that those are going to be congruent. So for my second one, by the definition of angle bisector, I know that angle WXZ is congruent to YXZ, and I also know, so that would be these two angles here are congruent. I should do it that way. And I also know that this angle here is going to be congruent to this angle here. So angle WZX is congruent to angle YZX. Okay? So now I'm looking at this. I have two angles. Okay? So I can use either. These are the 4 types of congruency that I have available to me. Since I already have two angles, I'm going to choose either angle side angle, because there are two angles, or side angle angle, because again, I have two congruent angles already. So that means that in either one of these, I just need to find another side. Okay, when I'm looking at this, side angle or angle side angle tells me the included side. Side angle angle says it can be one of the other two sides. I'm looking at this and I can tell that YZ is congruent to itself. So right there, that's going to give me angle side angle. So that's what I'm going to write next. 3 XZ is congruent to XZ. And that would be the reflexive property. And now that I have angle side angle, I can say that triangle WXZ is congruent to triangle YXZ, and that's by angle side angle. And they want me to say that, they want me to show that XY is congruent to YW. Well, I can do that because they're corresponding parts of these two congruent triangles. Okay? So number 5 is XY is congruent to XW. Y, you can do definition of congruent triangles. And basically what that says is corresponding parts of congruent triangles are congruent. Okay? And that proof is done.